Durable is a research program funded by Interreg Atlantic Area Programme of European Union as the main objective of transferring innovative previous developed technology from aerospace field to the renewable area.
In the Atlantic area, most of the countries are below the European Union objective of 20% of the energy produced in 2020 by renewable energies. This is why the challenge in Durable project is to improve the operational expenditures.
The Durable Consortium gathers 13 entities from all 5 countries of the Atlantic area. There are 2 French partners, STIA, which is the coordinator of the project, and Balemo, Dublin City University from Ireland, University of West England from the UK, Instituto Superior Técnico de Lisboa and DDP from Portugal, and 7 Spanish partners, 3 from the south from Andalusia, which are CTA, University of Seville and CATEC, and 4 from the north from the Basque Country, which are Alerion, Lortec, the Basque Energy Cluster, and Ingeteam.
So the work is divided into 3 steps. The first one is to match the need of the end user and the possibilities of the providers of technology to be able to develop them. The second part is to develop the technology with the possibilities of each one. And the third one is to make a mock-up to let the demo site to test the technology provided in the project.
A map of robotics and aerospace technology is being elaborated in the framework of the Atlantic area, and in parallel we're also developing a map about the needs of the solar and wind sector, focused on operation and maintenance, and we are also ranking these needs. The matching between these 2 analyses bring us identification of the most useful technologies that we have for these sectors.
Ultrasonics and thermography are inspection methods used in the aerospace industry for quality assurance during manufacturing or in service. Drone inspections using thermography are not new, but we try to increase the detectability of the method by increasing the payload of the system, and we can use in this way more sensitive to cameras. More challenge is the usage of ultrasonics contact inspections that will be applied for inspection of wind blades.
The maintenance and repair technologies that will be used are additive manufacturing, composite repairing, and virtual and augmented reality. These technologies have been joined in aerospatial sector, where short lead times, high quality, and waste saving are of high importance. All these advantages might be also interesting for reparation of solar panels and wind turbines.
We will develop and design tests for the different features of the proposed solutions. Then we will carry out those tests in relevant industrial sites and in actual real scenario sites.